Today we're going to talk about nth roots and radicals. We know that 5 squared is 25. So since 5 squared is 25, we say that the square root of 25 is 5. We write the square root of 25 is 5. And so since 5 to the third, or 5 cubed, is 125, we say the cube root of 125 is 5. So we write it like this. The cube root of 125 is 5. And since 5 to the fourth is 625, then we say the fourth root of 625 is 5. So we write it like this. The fourth root of 625 is 5, and so on. So you notice when we're talking about a square root, then there's no little number here. But if we're talking about anything higher than that, then we have to indicate what nth root we're talking about. So then comes the pattern. The pattern leads to our definition of our nth root, where we say if a to the n power is b, then we say that the nth root of b is a. So in other words, if the cube root, if 5 cubed is 125, then the cube root of 125 is 5. So we're talking about the nth root, where n is the little number here, and n is called the index of the radical. We'll talk about more about that in just a second. So next we're going to talk about how many roots a radical will have. Since 2 to the fourth is 16 and negative 2 to the fourth is also 16, when we talk about the fourth root of 16, the fourth root of 16 could be 2 or it could be negative 2. Notice my index is even. But when I'm talking about the cube root of 125, the cube root of 125 is only 5. Only one real root. Notice my index is odd. And if we're talking about the fourth root of negative 16, what number to the fourth power would give me negative 16? That would be no real roots, because we know that any number raised to the fourth power will never be negative 16. So this little table gives us an idea of how many real roots an nth root would have. And so when we're talking about the type of number, we're talking about the number inside the radical, which we call it the radicand. Remember that? So when our radicand is positive and the index is even index, radicand positive, means 2 real roots. Index is odd, but the radicand is still positive, means 1 real root. If the index is even or odd, but the radicand is 0, we'll say there's 1 real root and it will always be 0. Now, if the radicand is negative, we come into a problem, because if the radicand is negative, but the index is even, we know there are no real roots. But if the radicand is negative, but the index is odd, then we can still have 1 real root, because a negative times a negative will give me a negative. So that's what this little chart is. So we remember, if the index is even, 2 real roots. Only if the radicand is positive. If the radicand's negative, then no real roots. Or if the index is odd, there will always be 1 real root, no matter if the radicand is positive or negative. So here's some terminology. The radical sign, we know what that is. The number under the radical is called the radicand. We know what that is. The index gives the degree of the root. So that's the little number in the radical symbol. The little number that tells me what root I'm taking is called the index. We also talk about simplifying radicals a lot. So therefore, we have to bring up the principal root. The principal root is the positive root. So when the index is even, if the index is even, then we know that technically there are 2 real roots. But when we're simplifying, if I ask you to simplify the square root of 25, then you just talk about the principal root is just 5. If I ask you to solve, so simplify means we want the principal root. But if I ask you to solve the equation that says x squared is equal to 25, if you're solving, that's when you need to worry about plus or minus. If I have to take the square root of both sides, then I would want plus or minus. So we're going to look at some equations where we have to take the fourth root of both sides in just a minute, and we're going to have to remember that. Okay, so we can simplify, find each real number root. Real number roots, we're just looking for the real ones. So the cube root of -8 is -2. The square root of -100 does not exist. We know that. So we were going to say that there's no real root here. The fourth root of 81 is what number times itself 4 times gives me 81, and that would be 3. And if I'm not sure, then I'm going to go to my calculator and I'm going to check. So your calculator will do a fourth root, and it's under the math button. The math button, number 4 gives me the cube root, and number 5 lets me change the index to anything I want. So I can do the fourth root of 81 on my calculator, and it's 3. And so remember, this is talking about the principal root because we're just simplifying. So the square root of 49 is just 7. Okay, so we've got one more rule before we start simplifying. The rule is called the property where the nth root of a to the nth, I'm going to highlight this, the nth root of a to the nth is the absolute value of a when n is even. So we're going to look at some examples and we'll see when we need to apply that. So what we're talking about here is the square root of x squared is the absolute value of x. The fourth root of x to the fourth is the absolute value of x. The fourth root of a to the fourth would be the absolute value of a. Notice the index and the exponent are the same, and we end up with an a or an x to the first. If I were to find, and we're about to do this, find something like the fourth root of y to the 8th, I'm going to say that that's y squared. I'm not going to say it's absolute value because the index and the exponent are not the same. Okay, so let's do a few examples where we simplify some square roots with variables. The square root of 4x to the 6th would be 2x to the 3rd, because x to the 3rd times x to the 3rd gives me x to the 6th. The cube root of a cubed b to the 6th would be a b to the 2nd. And the fourth root of x to the 4th y to the 8th would be x times y squared, except we need an absolute value around x because we've got the fourth root of x to the 4th, which is the absolute value of x. And lastly, the cube root of -27 would be -3c to the 2nd. So if you notice, we have a pattern here with how we get our answer, our exponent of our answer. If you notice, we divide the exponent by the index every time. That gives us our exponent of our answer. Okay, so we're going to go down now here to this cube root of 64. If we want to check on our calculator, I'm going to go to Math 4. I'm going to check for the cube root of 64, and I know that there's one real root here, and it is 4. So the cube root of 64 is 4. Now, if we raise something to the 1/2 power, that means it's a square root. So 4 to the -1/2 is 1 over 4 to the positive 1/2. And I know that 4 to the 1/2 is the square root of 4. So if we're talking about something to the 1/2, that's the square root. If we're talking about something to the 1/3, that's a cube root. And if we're talking about something to the 1/4, that's a fourth root. Okay, now we're going to go down to, we can use our calculator to estimate these, so that's not hard. We'll be able to do that. But let's go, and we've already looked at these. So I want to solve a couple of equations, and then we'll look at a couple of homework problems. Okay, so the first thing I'm going to do here, since I'm solving for x, is I'm going to divide both sides by 6. So I get x cubed equals -216. Let's check to make sure. -1296 divided by 6 is -216. Okay, so the next thing I'm going to do is, since it says x cubed and I'm solving for x, I need to take the cube root of both sides. So the cube root of x cubed is just x. That's not the absolute value because n is not even. But we need the cube root of -216. So I'm going to go to my calculator and do Math 4 for cube root of -216. And I get -6. And if I got a decimal, I would just round. So we get a 1 real root, remember, because we're taking a cube root. If it was a fourth root or a square root, this is the time when we need plus or minus. Remember, simplifying, principal root, solving, plus or minus. Okay, so for this one, we're going to add 25 to both sides. We get x to the 8th equals 15. So since I have an x to the 8th, I need to do the opposite of x to the 8th, which is the 8th root of both sides. So I'm going to take the 8th root of both sides. The 8th root of x to the 8th is just x. And I'm going to go to my calculator to approximate the 8th root. I'm going to do math 5, the 8th root of 15, which is approximately 1.403. Okay, let's do one more like that. We're going to add 14 to both sides. So x cubed equals 36. Take the cube root of both sides. The cube root of x cubed is x. And we're going to approximate the cube root of 36. I'm going to go to math 4 for cube root. Cube root of 36 is about 3.302. 3.302. And it's not a plus or minus. I'm missing a plus or minus. Did anybody notice where I'm placing my plus or minus? Right in number 16. I knew I took the 8th root of both sides and the index is even, so I need a plus or minus in this case. Okay, so the only thing I want to do now is to go to the homework page. So I'm going to go to the homework page here, and we're going to cut one of these together. I'm going to talk about how we simplify a cube root, or a 4th root, or a 6th root, very similar to where we simplify a square root. Okay, so we know we can do a factor tree when we do square roots and look for pairs. But if I'm simplifying a cube root, then I need to look for not pairs, we need to look for triples or a perfect cube. So if I do a factor tree for 16, I get through 4 2s. So I'm going to circle the one of a group of 3 because it's a cube root, and I know something times itself 3 times is what a cube root is. So I end up with the cube root of 2 cubed there. So the 2 is going to come out of the radical, and we're going to multiply it times the 8 that's already on the outside. So negative 8 times 2 is negative 16. And what's going to stay inside the cube root is the 2 that I didn't circle. And then I'm going to take the cube root of x to the 9th. And remember, the rule is I can divide the exponent by the index, and I get x to the 3rd. If it didn't divide evenly, I would have some left over in the radical, wouldn't I? So that's going to help you with your homework.